Alright, so here we've got another electromagnetics question. We're told a solenoid produces a magnetic field of 0.25 teslas in the middle. Find the coil radius if the flux is 5 milliwebers. So we know that the flux is equal to the field times the area times the cosine of the angle. Now for this question we're going to assume cosine theta is equal to 1 because we're directly inside a solenoid. So we have flux is B times A. Now we know that the area of this shape is pi r squared because it's a circle. So we can actually plug this in straight away. This is going to give us flux is B times pi times r squared. If we divide both sides by B pi, this gives us r is equal to the square root. So divide both sides by B pi and then take the square root. This gives us the radius will be whatever the flux is divided by the field times pi. So now all we need to do is we need to find the flux in Webers and we need to find the field in Teslas. So we know that the field B is 0.25 Teslas. So this is 2.5 times 10 to the minus 1 Teslas. We know that the flux is 5 milliwebers. So flux is actually 5 milliwebers. This is 5 times 10 to the minus 3 webers. So now we're just going to plug these in. This tells us the radius is the square root of 5 times 10 to the minus 3 divided by 2.5 times 10 to the minus 1 times pi. So we're going to put this in our calculator. Be very careful to put this in the calculator correctly. Make sure you have all the negatives in the right places. 5 times 10 to the power of minus 3 divided by 2.5 times 10 to the minus 1 times pi. My calculator is telling me that the radius is 7.978 ... times 10 to the minus 2, and that is going to be in meters. So this is the answer that we're after for this question.